presenting a standard test for particle size analysis of soils, in accordance with ASTM D421 and D422. To begin testing, obtain approximately 200 grams of air-dried soil from your bin. Zero a bowl on the scale and pour 60 grams of pulverized soil into it. Record the mass of the total pulverized sample. Obtain a nest of sieves and make sure they are clean from previous sieve analysis. Record the sieve numbers, sizes, and mass on the data sheets. Properly nest the sieves with a lid and pan. Pour the sample from the bowl into the top of the sieve and place the lid on top. Place the stack of sieves on the sieve shaker and mechanically sieve the soil for approximately 3 minutes. Measure and record the mass of each sieve and the pan with the retained soil. Determine the mass of the fine fraction passing the number 200 sieve by subtracting the mass of the pan from the mass of the pan with soil. Taking care to not lose any fine particles, transfer the mass retained in the pan into a boat on the scale. Zero the scale, then add 125 milligrams of sodium hexametaphosphate solution to a 250 milliliter capacity beaker. Carefully transfer the particles passing the 200 sieve into the hexametaphosphate solution, making sure to add at least 15 grams. Record the mass added to the solution. Rinse the tray carefully, making sure all solids are transferred into the beaker. Stir the solution, making sure all solids are wetted, and let it soak for approximately 16 hours. Add distilled or demineralized water to the beaker until it is approximately half full. The exact volume of the water does not matter at this point. Transfer the dispersed solution to an empty 1000 milliliter graduated cylinder without losing any particles. Carefully use the water bottle to wash any residue from the cup during the transfer. Also use the water bottle to wash any residue from the sides or rim of the graduated cylinder. Fill the cylinder to the 1000 milliliter mark using the bottom of the meniscus with distilled or demineralized water. Insert a rubber stopper into the test cylinder and mix the solution by turning the graduated cylinder upside down and back for 1 minute, a full 180 degrees, to complete the dispersion process for the soil and the sodium hexametaphosphate. Remove the rubber stopper and make sure none of the sample is stuck to the bottom. Carefully lower the hydrometer into the soil solution without allowing it to bob. Do not drop it in. Record the hydrometer reading at the top of the meniscus. Continue to insert the hydrometer into the graduated cylinder approximately 30 seconds before each reading time specified on the data sheet. Be sure to record the hydrometer reading and the temperature at each specified time until the last point is obtained at the 24-hour mark. For the final calculations, begin by calculating the hygroscopic correction factor, which is the mass of the water content can containing dry soil divided by the mass of the water content can containing wet soil. Next, subtract your hygroscopic correction factor from your actual hydrometer reading to get your adjusted hydrometer reading. To find the percent finer value, you must multiply the adjusted hydrometer reading by a correction factor listed in Table 1 of ASTM D422, and then divide by the oven dry mass of soil. The final equation is used to calculate particle diameters, which can be placed on the x-axis of a particle size distribution curve in logarithmic form, with percent passing on the y-axis.